Hello everyone, welcome. Welcome to my YouTube channel. My name is Aditya Maurya, currently pursuing BE in Sri Venkateshwara College of Engineering. So my USN ID is 1BE23CA004 and I am currently in second semester, section D. So today we will be discussing a small topic in civil. So the course code is BESCK 204A and the course title is Introduction to Civil Engineering. And today we will be discussing how to calculate the centroid of a particular given figure. So okay, let's get started with this thing and have a better understanding of centroid. And also we'll take up a problem to understand centroid and we'll solve the problem in order to get the centroid of the figure, the given figure. The figure will be divided into 4 different sections. We'll just figure out which is which and then we'll apply all the formulas and also calculate where is the centroid of the figure. Okay, so first, what is centroid? In civil engineering, the centroid is a crucial concept used to determine the center of gravity. Centroid is nothing but used to determine the centroid of center of gravity or the geometric center of a structure of a body. So for example, if I were to take this pen, what is the center of this pen? So if I am to hang this pen, which is to stand in equilibrium on both the sides, I won't hang it this side. If I do it this side, it will go down like this. Or if I do it this side, it will go down like this. So in order to hold it like this, there will be a center of this. So if I hold it like this is the center of the pen. That is nothing but centering. The center of gravity or the geometric center of a structure or a body. It is a fundamental concept in structural analysis, particularly in the design and construction of buildings, bridges, design and construction of buildings, bridges and other structures. So, now what is the definition of centroid? The centroid is the point where the weight or mass of an object is evenly distributed, and it is the average position of all the points in the object. We read this again. Centroid is the point. It is a point where the weight or mass of an object is evenly distributed. So if this is the centroid of this object, the weight is evenly distributed on both the sides of this pen. That is why it is in equilibrium and standing here. Or else it would have fallen apart like this. And it is the average position of all the points in the object. So, what are the steps to calculate centroid? First, identify the given reference axis. What is the reference axis given? It may be either the x-axis like this or the y-axis. There will be some figure something. So just identify which is the axis first. And then if the reference axis is not given, consider the bottommost part of the figure as an axis. Okay. So if there is a figure which is like this and there is no reference axis given. So in order that, just consider this bottom line as your x-axis and the leftmost part as the y-axis. Consider this. Check for symmetry of the figure. So now that we have chosen the reference axis, so now let's get to checking if there is symmetry in this figure. Symmetry should be on both the sides, that is on x-axis and also on the y-axis. If the figure is symmetric about its vertical axis, then x is equal to total width of figure divided by 2. If it is symmetrical about the vertical axis, the y-axis, we will do the total width of the figure divided by 2. X is equal to total width divided by 2. And similarly, symmetrical about horizontal axis, y is equal to total depth of the figure divided by 2. This is this total depth, this is the depth and this is the width. And when it is symmetrical about the horizontal axis, that is like this. If you cut this triangle into two parts, if it is symmetrical about the y-axis, just do total width by 2. And if it is symmetrical about the x-axis, like this, if you get symmetry on the x-axis, so just do total depth divided by 2. This will be your 1. If a figure is symmetric, then divide the composite section into non-geometric figures. Determine the centroid using the following tables. Okay, so there are two things in this thing. The first one is a triangle and the other one is a circle. So we'll distribute this thing into two. We'll take this one as 1 and then this two as 2. And then we'll do all the required things, whatever we need for the solving of this thing. Okay. Just ignore this thing. So now, to calculate the centroid, we'll use this particular table. We'll divide it into this particular table and write all the data here. First thing is the component, so we can just take it as triangle as the first component and the circle as the second component. So first we'll calculate what is the area of the triangle, and then centroidal distance from x-axis, that is for y, and centroidal distance from y-axis, that is x, moment of area about x-axis and moment of area about y-axis. So we'll get to all the formulas. We'll get all these formulas in the next page for how to calculate the area, the centroidal distance from x-axis, the centroidal distance from y-axis, the moment of area about x-axis, and the moment of area about y-axis. We'll get all this formula in the next page. Okay, so first, centroid of some important geometrical shape. If we take a rectangle, we can also consider it for the square. First, for the rectangle, the area we can consider as BD, B into D, that is breadth into depth. So we'll have to, if we have to find out the centroid distance from x-axis, that y-axis, centroidal distance from y-axis, that is x bar, we'll just use b by 2. And if we have to calculate y, we'll calculate by using d by 2. So x is this thing, x bar. So you'll just use b by 2 to calculate this thing, and y bar is this. You'll just use d by 2 to calculate the centroid. Same for the triangle. We know the area, half breadth into depth, or half b into height, breadth into height. And for x-axis, that is like this, we can just use b by 2. But when it comes to y-axis, we'll have to use 1 by 3d. This is the way. We'll have to use 1 by 3d. And then for the right angled triangle, we know the area, half breadth into depth, and then the centroidal distance is half 1 by 3b. So that is 1 by 3b. It is 1 by 3b like this and 1 by 3b like this. So we'll get the centroid somewhere here. For the circle, it is x bar is equal to r and y bar is equal to r, because it does nothing but the radius where the circle is, the center point of the circle stays. And then for semicircle, there are different. So area we can just take as pi r square by 2. When it comes to x bar, it is d by 2, depth by 2, d by 2. And y bar is 4r by 3 pi. And if it is on the negative side, we just take negative. If it is on the negative side, we take it as negative or the positive. For quarter circle, that is a quadrant, we take the area as pi r square by 4, and the x bar is 4 by 3 pi, calculated using by 4r by 3 pi. And the y bar is also calculated by using 4r by 3 pi. So we'll be using all these things, all these formulas, and calculate the centroid. The data will be already given. What is the breadth and depth of the particular figure will be given in the question. Now let's take the question. So now we see there are 1, 2, 3 and 4 sections. So first one we can take as a triangle. Second one we can consider a rectangle. Third one a right angle triangle. And the fourth one also a rectangle. You can see the dimensions given here. The dimensions are 1.5 meter here, 5 meter is the height of the triangle, and 4 meter is given here. 4 meter is width of the triangle. Here the height of the rectangle is given 1 meter, And width you can just calculate using 4 meter plus 1 meter like this. So 4 plus 1, 5 is the width. And then for this one, you can just use 5 meter plus 1, that is, this will be your 6 meters. This is your 6 meters, and this is your height, and this is your breadth, that is 2 meters. Same for this thing. So you can just use 1.5 plus 5 plus 1, that is 7.5. 7.5 is your height of this rectangle. And the width is given here, that is 2 meters. So now let's calculate all this thing in the next bit. Okay, so first thing we'll take the triangle one. What is the triangle? This is the triangle. Half breadth into depth. What is the breadth of this triangle? Okay, so half depth into breadth, that is half depth. This is your 6, 5, this 5 plus 1, the height is 6 and the breadth is 2. We'll put this thing into the formula and calculate area. Same goes for the rectangle 2. For the rectangle 2, this is rectangle 2. Your depth is 7.5, this 1.5 plus 5 plus 1, which sums up to 7.5 as your depth. And the breadth is 2 meters, which is nothing but here. Breadth into depth, that is 15. Same goes for the triangle number 3, half 4 into 5. Half 4, that is this thing, 4 into 5. This is 5. This is 4 and this is 5. And for the rectangle number 4, this is your 5 as the breadth and 1 as your height. Now, x bar is calculated from the centroidal distance from the y-axis. So that is 2 by 3 into 2 will get as the value 1.33 and y bar will get 1 by 3 into 6. Now, ax is calculated using area that we got here and x value over here. So 6 into 1.33 will get 7.98 and 6 into 2 will get us 12. Same goes for the rectangle 2. 15 into 3 will get us 45 and 15 into 3.75 are going to get 26.25. For this thing, area is 10 and area into x-axis you're going to get 53.33 and 10 into 2.67 you're going to get 26.67. Same for this thing, 5 into 0.5 you're going to get 5 into 6.5 you're going to get 32.5 and 5 into 0.5 you're going to get 2.5. So now we'll have a summation of all this thing. We'll calculate the sum of all the areas first. So we are going to get summation of A as 36 and summation of AX as 138.81 and summation of AI as 97.42. Just add all these, you are going to get this. Now to calculate the centroid, we have this particular formula. X bar is equal to summation AX divided by summation A, which is equal to 138.81 divided by 36. 138.81 is from here and 36 is your area. If we calculate this thing, you're going to get 3.856 meters. And for the y-axis, you're going to get 97.42 divided by your 36. So you're going to get 2.706 meters. So your centroid lies at 138.81, 2.706. So yes, this is your centroid of the figure. So I hope you understood all the things in this particular thing, and once again to give you the formula or just a minute. So here you go. These are the formulas that we've used in the calculation of the centroidal distance from x-axis or the y-axis, that is x bar and y bar. Use all these things to calculate your formula. So I hope you understood the entire video. I hope that you understood how to calculate the centroidal distance of a figure. So if you did so, please like the video and also comment, and I'll see you in the next video. Thank you.